Hello guys, today we're going to learn on how to solve for variable and super logarithmic equations. This is version 2. So let's go do the review. Log with finding the base. Log base x of 4 is 2. I need to convert to exponential form. X squared is 4. I need to take the square root of both sides, but the plus or minus square root of 4. Now the 2's cancel, giving us x by itself. X equals plus or minus 2. No, that's incorrect. Do you know why? We can split that up into x equals 2 and negative 2. But negative 2 isn't in that. So we can't have a negative base or a negative argument inside of logarithm. So x is equal to 2. That's the correct answer. Make sure you plug in log base 2 of 4 is 2. Yeah, because 2 squared is 4. Okay. Let's go to a super logarithmic equation. Okay. So let's go to super logarithm. Base x of 4 is 2. I need to convert to rational form. X rated to 2 is 4. Now, instead of taking the radical of both sides, I need to take the super root of both sides. Now, I don't want to apply the plus or minus because, yep. So these will cancel. X is equal to, I know that 2 rated to 2 is 4, so that means x is 2. Let's go to another example. The super logarithm base x of 256 is 2. Now, I need to convert to tetrarational form. X tetrated to 2 is 256. I need to take the super root of both sides since we're finding the base. The 2's cancel, giving us x by itself. X equals, I know that 4 tetrated to 2 gives us 65,000. 4 tetrated to 2 is 256, so that's the answer. Let's go do another example. The super logarithm base x of 65,536 is equal to let's go do 4. Okay? X tetrated to 4 is 65,536. I converted it to tetrarational form. Now I just gotta take the super fourth root of both sides since the 4 cancel. I know that the 4's cancel, giving us x by itself. X equals the fourth root of, super fourth root is 65,536, which equals 2. X is 2 because I can check my work. Super logarithm base 2 should have been 2 of 65,536 is equal to 4. Let's go compare that to 4. So let's go evaluate log base 2 of 65,536. I know that 2 tetrated to 4 is 2 squared squared squared. I can replace 2 tetrated to 3 with 16, which equals 65,536. And now 4 is the correct answer. So 4 is 4. So x equals 2 is indeed correct. Let's go try another example. The super logarithm base x of 2 raised to 65,536 equals 5. I need to convert to terminational form. X terminated to 5 is equal to 2 raised to 65,536. Now, I need to take the super fifth root of both sides to get x by itself. X is equal to, I know that 2 terminated to 5 is 65,536. I mean, 2 raised to 5 equals 2 raised to 65,536. So 2 is indeed correct. Okay? Let's go to another example. The superalgorithm base x of 2 raised to 2 raised to 65,536. Here's it gets tricky. Now I'm pretty sure this is not tricky. So x raised to 6 is equal to 2 raised to 2 raised to 65,536. I gotta take this to super sixth root of both sides to get x by itself. So that means x is equal to, I know that 2 raised to 6 is this one. 2 raised to 2 raised to 65,536. Because 6 minus 1 is 5. I just gotta exponentiate another 2. I know that 2 raised to 5 is 2 raised to 65,536. That's how you can check your work. Make sure there's no negatives. No negatives at all. Okay? No negatives in like logarithms. And probably for super logarithms also. But yeah. Okay. Let's go do one more. The super logarithm base x of 2 raised to 2 raised to 2 raised to 65,536 equals 7. Let's go convert to terminational form. X terminated to 7 equals 2 raised to 2 raised to 2 raised to 65,536. I gotta take the super seventh root of both sides to get x by itself. Now, those sevens will cancel. X is equal to, let's go try 2. If it equals to 2 squared raised to 65,536, then that means x equals 2 is correct. So let's go check our work. I can rewrite it. I can rewrite 2 raised to 7 as 2 raised to 2 raised to 6. Okay? 7 minus 1 is 6. And then I know that 2 raised to 6, 2 raised to 6 is 2 raised to 2 raised to 65,536. 2 raised to 2 raised to 65,000. I don't have enough space. Indeed, x equals 2 is correct. Bye guys. I hope I see you in the next video. Bye.